Next up we have the chair of our Human Element Working Group, Mr. Martin Shaw. Martin will be presenting on the recognition of the human element in equipment and procedures of maritime operations and the need for development of a new paradigm to address what is really behind human error. Martin, thank you very much.
Thanks, John. Just a bit of background. I'm a marine engineer. I was at sea in my younger days. I came ashore, took a year off to become a chartered engineer, persuaded my then employers to put me through an MBA a few years later. So I have a background in engineering, I've got a background in business, and I have a passion for the human element because I've managed lots of people in my time, and sometimes think they're the least understood and least cared for bit of our environment. Let me just talk very quickly about what I will be talking about, following the sort of normal context of things. A quick outline, I'll give you a bit of context about the Human Element Working Group. I'll talk a bit about what the current paradigm is, talk a bit about what the problem is and the future, and I'll hopefully come to a conclusion, but I'm not certain of that. This is a quick advert for the Human Element Working Group. Our mission is to improve safety. Well, you can read it. I won't bother reading it. You can read it. I really just wanted to make sure you understood the context, because a lot of our discussions have been about science and things like that. And I just wanted to make sure that you understood that our main driver is to do with safety and how things are actually done at sea. We've got a Human Element Working Group committee of 16. We have a very active Nexus group of 115. And when I say that during this week, the subjects have included such things as Donald Trump's views on aviation safety. It's a safe place to discuss things, so come along and join us. It doesn't need to hurt very much. And there's a correspondence group of somewhere in the region of 200 people behind that. We also have a website. The website runs to about 30 or 40 pages of information about the human element, and those pages are absolutely filled with links and documents, and we are continuing to develop those as time goes by. So come and join us. That's the advert over. So let me talk a bit about the current paradigm. We've talked a lot about inhabitants of the sea today, and I want to talk about an inhabitant of the sea that's at risk. The numbers of this species have reduced remarkably over the years, and sometimes we feel they're neither valued nor respected. Sometimes they're even seen as a predator. Recently, there's been a discussion about removing them from the habitat. I'm talking, of course, about the seafarer. There are two sort of paradigms, or two views of the current paradigm. There is the blunt end view, the blunt end being the sort of the end that the regulator sits at, and that view is that people are provided with perfectly good ships, beautifully designed, and everything is fine on them. They're provided with perfectly good operational procedures, and their procedures are designed by geniuses. Why do they keep making stupid mistakes? On the other side of it is this picture here, which is a poor unfortunate on board ship who is wrestling with the complexities of technical factors and organizational factors, and is desperately trying to make them work. And the argument I would make is that the only reason that the current generation of ships do work is because there are people on board them fixing the problems and making them operate. So that's me sort of declared my position very, very clearly. Let me talk about a bit of history. This picture will appear several times, but what I'm really trying to say with this picture is that as safety has improved over the shipping industry, it's improved in phases. It hasn't been one continuous improvement. So you'll see that we go through a phase, we come up with a paradigm that we like, it gets adopted, everybody uses it, and then eventually the laws of diminishing returns get involved, and it starts to turn around and head in the other direction. So the traditional view was that we concentrated on developing the hardware. We looked at the competence of people, and we were supported by regulations, and we were supported by a developing view of industrial safety. So that to me is my traditional paradigm and my starting point. This is a traditional ship built in the 1960s, 54,000 ton crude carrier, single hull, steam turbine, all these bits are history now. 54 officers, no collision avoidance radar, sat-nav or anything like that. Engine room watchkeeping was carried out. There was minimal instrumentation, no ISM, no rules, nothing like that. This is a traditional seafarer. You won't believe that My wife tells me that I still have beautiful legs. And I've hardly aged a day since that picture was taken. But as a young engineer cadet, which I was in those days, and I stress that I sailed in that 1960s ship about 15 years later, just to begin on the clear side of that, you tended to learn by being taught by your betters and your elders. You generally had 3 or 4 people on a watch, and the senior watchkeeper had a personal interest in making sure that you were doing things right, because it was his ticket that was at risk if things did go wrong. So that's the sort of traditional ship. So how things got better, that's probably a good place to start. This is a picture of total losses since the 1980s, and you can see that the good news is that the casualty trend has gone down. Things have got better, things have got safer. There are a few points to make. One is there's a big blip about 1990, and that big blip is what got us into our next paradigm. The second thing to point out is that Von Pomeroy, who's one of our members, did a calculation based on the airline industry, and if you look at our safety record, losses at present, and compare it with the airline industry, it's actually equivalent to an airliner going down every 2 weeks. So it's not that good. We've still got a long way to go to make things better. It's also worth saying that fatalities at sea are 12 times the average, and that's in the UK flag fleet rather. And 4 times actual manufacturing industry sort of standards. So that there's a job to do. There's an improvement to make. This is again taking my sort of paradigm bit. The traditional paradigm that I talked about kind of ended in the 1980s, 1990s. Lots of change, lots of rapid technological change. There were the oil shocks. The oil shocks in the tanker business drove low freight rates. There was a sort of casualisation of the labour force, and there was a race to the bottom on costs during that sort of long low freight rate period. And one of the issues behind it, of course, was there were some questions as to the effectiveness of compliance. So people were quite happy to go for the lowest quality, lowest standard, cheapest operations, which moved us towards another paradigm, which is what I describe as the procedural paradigm, which is based very heavily. Excuse me a minute. I had a glass of water right here. Just in case. Planning ahead, very important subject. But we moved to a procedural paradigm, which is very heavily focused on procedures, on management systems. It's supported by a whole load of other things. But there was clearly a lack of procedures in the industry in the 80s and the 90s. As time has gone by, that has sort of evolved a little bit. And there are problems with that current paradigm. So let's just start with very quickly, what are the problems? One is things that have happened before happen every day. The things that have never happened before happen every day. My apologies. This comes from a very interesting book by a guy called Scott Sagan called The Limits of Safety. And it's a book about the safety of nuclear weapons. The bad news is that one of his closing statements is the only reason that there wasn't an unintended nuclear release was the end of the Cold War. And I'm not convinced we're in that world anymore, looking at what's going on around us. But it's a very interesting book. But his premise is, because the world is getting more complex, we keep finding new ways of making things go wrong. This is Shaw's corollary to that. In the marine industry, things that have happened before happen every day in different ways. We're finding new ways to ground ships, collide ships, and blow them up. The industry has become more complex and less predictable. Is really where I've got to with that statement. So let me just talk a little bit about the procedural paradigm and did it work. This is an excellent slide that Intertanko have produced for many years, but then stopped. I know somebody who used to work for Intertanko. I'd love to know why they stopped producing this slide in 2015. But it is an excellent slide because it shows two things. It shows pollution, And let's get some good news into the room about what the marine industry can do when it gets its act together. If you look at the black bars, those are pollution incidents. And if you look at the black bars, you'll see how far those black bars have fallen, to the extent that over the last few years we have had next to no accidental releases of, or major accidental releases of oil into the environment, which is clearly good news. We had one recently, the Sanchi, which was an Iranian vessel that was involved in a collision off China. So it's not something we can forget about. Oil pollution is still a very real issue. We should also remember that in the oil industry, as a result of IMO regulations, we got rid of a thing called cargo ballast tanks, which was a mechanism by which you slopped water into a ballast tank that had oil in it. You then cleaned the tank and then discharged the hopefully clean water over the side sometime later down the line. An early ballast exchange procedure. I just wonder whether going to segregated ballast tanks and giving all these critters clean water to play in has been a bad thing because of that. But that's something for the scientists, not for me. As I said, you can see that the sort of graph is heading downwards, but flattens out, and that brings in the law of diminishing returns. And to me, we went through a number of phases with these sort of improvements that procedures brought along. The first thing we did was relearn the things that we'd forgotten, which was very effective. The second thing was created processes by which we could learn ourselves and change things in our own organisations. And then the third phase, it flattened out because there were limited common causes that people could find in their investigations, and the law of diminishing returns kicked in at that point. This is an interesting sort of adaptation of new technology, because I did think about how I was going to do a quick transitional build in the second half of this slide, and then remembered the old days of overhead projectors, when you put a piece of paper over the one side of the slide and took it away. So there's a piece of virtual white paper over this slide. And my argument would be that we are now heading in an upward phase with the procedural paradigm. The first stage is caused by increasing workloads as a result of a thing called the efficiency thoroughness trade-off. Long discussion to be had about that. The next phase after that is people are finding it more and more difficult to make decisions. So how do we deal with that? And finally, we get to complexity, which I'll come back to in a minute. Legislation. This is a couple of graphs of new legislation and new instruments coming out of IMO over the last few years, and you can see that things are clearly growing, and many of the things that are being produced are ending up aboard ship. So lots of new regulations. Very, very seldom do we see anything taken away. Making decisions aboard ships. This is, let me introduce the chap in the middle. His name is Chief Engineer McAvitar. And you'll see him again later in the presentation. But you can see that he has to deal with a whole load of difficult things on board ship. Conflicting goals. He has to deal with safety, emissions, greenhouse gases, ballast water treatment, piracy, security, making money, doing things quicker, doing the paperwork, and all the rest of that sort of stuff. You can see he's got lots of duplicated and conflicting requirements depending on whose instructions he's being forced to read at that particular point in time. There's lots of systems that he has to be involved with, and he's got all sorts of communications and emails that are coming to him from his office with offers of help. He's getting very tired of having that question mark stuck in his head. You'll see him later with the same thing on his head. I mentioned complexity. We get into complex technology. We've seen the problems that we had introducing the ECDIS system in the shipping industry, and one of those new ways that we found of running ships aground. We've seen the Arleigh Burke class destroyer collisions, one of the most sophisticated warships in the world. Normal operating procedure, I believe, was to steam with the AIS system off, the locating system off, and quite often to steam with the lights off, which left the only way a merchant ship had of seeing this stealth warship being their rather dodgy radar systems. And unsurprisingly, a couple of them have been involved in collisions. So, as we become more complex, things become more difficult. The Air France Airbus, another important decision, another important example to consider. It like the recent Boeing 737 collision, sorry, I'm getting myself mixed up here, crash rather, was very much about very advanced technology and how the people on board ship coped with that advanced cope with that technology when it started to break down. This brings in a thing called the irony of automation. The irony of automation is that if you rely on automation, you've actually got to understand what happens when it all shuts down, and you have to run it in the manual mode. And generally, we don't give people enough practice at running things in the manual mode. We also face problems with the reliability of control systems aboard ships, poor integration of those systems, and a lack of standardization. So all of those are things that we can do better on. Don't judge me for this slide. I'm an engineer, I'm not a scientist. So this is Martin Shaw's tutorial in complex adaptive systems. If any of you want to come along to the Human Element Working Group and give us more information on complex adaptive systems and resilience, please do. We're looking at things called like the ball and cup model of resilience and how it applies to seafarers. Complex adaptive systems, I'm sure you know better than me, are systems that adapt to perpetuate their existence. Insects are one of the great examples that people talk about. Ants are very successful at what they do, although we don't always view them as being successful because they can be difficult. This is Martin Shaw's views on the features and behaviours of complex adaptive systems. I'll let you read those, and I won't embarrass myself by reading them out, but those are my views on what a complex adaptive system is. As I've said, I've talked about insects. Let's talk about traders. We can see many reasons why we would believe that the world financial system is a complex adaptive system, and that traders are like those insects in the complex adaptive system, optimizing their own position at the expense of others. The question is whether Captain McAvitar is living in a complex world and has more question marks embedded in his head. Is this a complex system? That's the way that the shipping industry works. 5 minutes to go, okay. That's the way that the shipping industry works. So it's relatively simple and straightforward, isn't it? Until you consider the number of flag states, the numbers of recognised organisations, the number of tanker operators, and all the rest of that sort of stuff. Then various other bodies sort of come into the frame. Then we have port state, which was developed because there was a perception that flag and class weren't doing the job properly. And then in the oil industry, you developed the vetting systems because there was a perception that the oil majors would be at risk as a result of pollution and the liability attached to it. So you can see that's a pretty complex world out there. Oh, and by the way, there are oil traders in the middle of it as well, optimizing their position. So the future, IMO has a view of the human element. The human element is a complex, multi-dimensional issue. My summary of it is very quick. It says it's about everything that's all connected. And unless you get those connections right, then things will go dramatically wrong. It doesn't mention people. The word people is not used in that, which is interesting. This is a model of the human element. I'll not spend much time on it. You can find a whole load of information on this on our website. But again, it stresses the fact that everything is connected. This is a septagon which came from Michel Gresh, who was a member of our group. We did look at a limited version called the quadragon. It took us a while to realize we were talking about a square. Where are we now? This is where we should be now. We should be moving into the human element. IMO has said we've moved into the human element. My view is we haven't. We've stopped looking at the human element and we're just looking at seafarer human error. And that's one of the problems that we face. Human Element Working Group is dealing with that. We believe that we can help to change the world. We can help to move things towards the human element and eventually move towards something that I would describe as being resilient shipping. We are involved with a thing called the Human Element Industry Group, which is an association of NGOs at IMO. We have the International Chamber of Shipping, we have the ITF, we have a whole bunch of people who are working together, and we believe we are actually beginning to make a real difference in this sort of area at the moment. We have just invited the UK flag to join that group. It's been NGOs up until now. So lots of good things happening and lots of progress. Conclusions, I'm happy to say, I think I've just about hit the time limit. Safety has improved over 30 years. That's good news. The focus has been on procedures and human error to date. We need to move on to that because of the laws of diminishing returns and also complexity. Complexity is a real issue, I believe, on board ships, and as I've said before, I would really welcome the chance to talk about complex adaptive systems and resilience and things like that with people from the scientific side of the business that understand those things. The human element looks behind human error. We're looking at the individual and how they think and what they do. We're looking at the technical factors. We're looking at the organisational factors. And we have the Human Element Working Group and the Human Element Industry Group working together to try and achieve some of those things. Any questions?
Martin, thank you very much indeed. I think when we involve people in discussion, it can be quite an emotive subject, and the Human Element Working Group is doing a great job in managing some of those emotions and dealing with them. And I think the evidence of the engagement at the wider HEWG, at the Human Element Industry Group, and bringing along now the member states through IMO is a terrific example of some really good IMarEST engagement and work of that SIG. So thank you. Bev, we do have some questions.
We do. The questions are rushing in, so I'll try and keep up with them. So the first question is, as technology improves and is implemented, do you think engineers will be trained to navigate or navigators trained to be technicians? How do you see skills changing?
That's a tough one. We've been playing about with I believe originally they were described as polyvalent or something like that, polyvalent officers, right back to the 70s and the 80s. There has been quite a strong history of people who have done a dual ticket, just ending up going on deck. So I'm not convinced about how all that works. I'm an engineer. I'm trained as a navigator, but it's to fly a plane. So engineers can be trained to navigate. There's no question about that. And I can use my GPS system. I'm not convinced. I think there's still a room for two specialisations. I think there is a need for there to be two specialisations there. I'm not convinced that combining the two is necessarily the right answer.
Is micromanagement from shore, limiting permitted distance off track and permission required from office for anchoring, etc., is this helping or hindering safety?
Hindering safety, absolutely hindering safety. From the point of view, everybody has an email nowadays. You can have the captain and the chief engineer receiving instructions about operational matters from somebody who doesn't actually understand operations. Your priority is to get me the budget stuff today. Don't care if you happen to be in port at the time. So there are those sort of things. But there is far too much of the decision-making capacity has been taken ashore and from those aboard ship. The people on board ship are in the front line and know all the factors. They need support from onshore. They need advice from onshore. But to my mind, micromanaging from onshore is not a good thing. Apart from anything else, it demotivates people and they stop thinking.
And if we have 1 minute, I'm going to tie two questions together. You may want to answer them separately. Too many procedures can have a negative effect in that seafarers lose the ability to think. Do you agree?
Agree.
And also, is complacency a factor?
Is what, sorry?
Complacency.
Complacency. I'm not sure it's so much complacency. I think the biggest problem, it goes back to the procedural issues that you just mentioned. There is so much in the way of procedures, there's so much in the way of workload that the difficult thing for the seafarer is just getting through the day. So quite often they have to make compromises in what they can do to get through the day. It's not so much complacency as as more work than you can do in a normal working day.
Any more? Yeah, I believe. Okay. Okay, thank you for the questions, and thank you again, Martin, for your presentation.